I'm going to tell you a little bit about the equipment of the Kingston Historic Dry Dock. First of all, we see a diver's suit, and you might ask, why a diver? Well, divers were used to look under the waterline what damage the ship might have and what the repairs should look. So imagine yourself in a diver's suit of that era, which is your grandfather's time. He could be in there and work underwater. But to do that, he needs air. So we are going to pump in air through this hose into the diver's suit, and that air enters into the helmet and around his body. So he has air to work and air to breathe. So to get air into the diver's suit, we need to run this machine with these two flywheels. You can see that it also has a crankshaft that moves the piston rods and the pistons in the cylinder up and down. The crankshaft is offset by 120 degrees, and that means that each pump either sucks air in or pressures air out to the diver's suit. A very nice invention. So from here we will go on to other steam engines and show you how they work. So what you see here is a small steam engine, and it's a very special steam engine because it has a high pressure part and a low pressure part. The steam will go in here, enter through a valve system that you will see later into the high pressure cylinder. Then it goes out the high pressure cylinder into the lower pressure cylinder, and that moves the pistons up and down. I'll show you how that works. There is a wheel here that we can turn, and it shows the crankshaft moving, the connecting rod going up and down to the piston. So we will move our position to the front of the engine, and I show you how the steam valve works. So what you see here is the steam chest. The steam goes in here and is distributed from here into the high pressure cylinder and the low pressure cylinder. If I turn this wheel and turn the crankshaft, you can see the valves with the red stripes on them, so you can see them better, going up and down, and the mechanism of the valves is synchronized with the mechanism of the pistons. So this is a one-cylinder steam engine. You see only one cylinder here, but it has an interesting contraption at the top. So the steam goes in here and goes into the steam chest, and from there into the cylinder. But there is oil in here. In this container there is oil, and the steam pressure is part of this automatic oiler. So when the steam condenses in this pipe, it puts some water in this. The water displaces the oil, and a drop of oil goes into the steam intake. So steam goes in, a little bit goes into the automatic oiler, and oil is pushed into this pipe here, and then goes into the steam chest and to the cylinder. I like to show you how this engine moves. We have it animated by electricity. So when I push this button, you can see the flywheel, and you can see the crankshaft moving. And you can see the piston go up and down. So this is the other side of the steam engine, and you can see a mechanism that is actually driving the valves in harmony with how the crankshaft moves. So I'm going to start the machine. And these two little discs that make that funny motion, they control the steam valves that regulates how the steam goes in and how the steam goes out. So this is what we call a hit and miss engine. It is basically the earlier development of an internal combustion engine, so it is not a steam engine. It has a flywheel, a big flywheel as you can see, but it also would have a spark plug as you can see here at the top. So inside here is a cylinder and a piston rod. So this is just a hand wheel to move the engine as you can see. When I do that, the piston goes up and down inside the cylinder. And it drives the crankshaft and the flywheel. When there is enough fuel inside the engine, then the spark plug explodes the fuel, and that makes the engine go very fast. And then the exhaust gases come out here, and the fuel goes in there. So this is not a steam engine, but it's the forerunner of an internal combustion engine.